Welcome back. So before the break, we did stuff with the abstract classes to make this item system work pretty well, I think. But like I said, that was before the break. Now we're going to, well, ignore the abstract classes. That's not a part of the second part, because now we're going to talk about generic classes. But before I'm going to go into, go in depth about them, like how we use them, how we create them, I'm going to use one built-in one called ArrayList, and let's see how we can apply that to the inventory of the player. So the inventory at the moment is just an array, and then we define that as being 10 long. It's always 10 items long. What if we want to have a dynamic inventory? So if we add more items to it, we get more slots. If we remove items, we won't get like empty slots somewhere, so we just have a list of all the different items. Then we can use something called an array list, and we'll see why that is generic, because the class array list is something called generic, and we'll see exactly what that is in a bit. Okay, so instead of doing it like this, I'm just going to do array list, and then items, it can still be called items, and then we do new array list like this. And what we'll have to do then is, like, here we want to return the array list, and then so there are quite a few things we need to replace here, and here we want to import array list as well, like this. There you go, and then when we use it, we have to change a few things as well. Here we get the items from the player, so here we go. Here we will have to use an array list as well, and then we, instead of doing items.length for an array list, it's called dot size, like so. And when we get an item, we don't do it like this. We get it like that. Oops, it should be items here still though. Items.get, so we get the item like that, and we can use that. And of course size here, there you go, and then also size over here and size over here, right. And we should get it over here instead, so get. So there are just a few things. The syntax is a bit different with array list. Instead of referring it to it with like arrays, you have something called items, and then you refer to the method get, and then you give it the index as a parameter. And when we want to remove it like this, we just do items dot remove that specific index. So like I said, it's a bit different, but it should work pretty much the same. And then we can run it like this, but it's not actually going to work properly, because when we get it here, it's going to return an object for us. So what we'll have to do is to convert it to an item, and the same thing goes, where is it, down here. So we need to do like this, item, like that. Okay, so now alright, I forgot to. Alright, when we pick up the item, we actually no. So when we pick up the item, before we wanted to check for an empty spot, but now we just want to add it to the list. So what we do is items.add item. So very simple. It's just going to add it there. We could have like a check if the player has more than 10 items, then you're not allowed to add anything. If the player has more than 300 items, you're not allowed to add anything. If the player has like items that weigh too much in total, like you just carry like 300 pounds or something like that, then it might be like, well, too heavy, so then you can't add it. But at the moment, we're just going to allow the user to add it no matter what. And there you go. So the compilation worked, but we get some errors here. So unchecked call to add as a member of the raw type, blah blah blah. So it's talking about something called the raw type, and that's what we have here. We create a new array list here. We just created there, and then we can store items in it. And that's a raw type. We don't give it the specific type, and that's what generics are. So a generic class asks us for a type, but if we leave it out, it's still sort of going to work, and it's using object, the superclass of all classes, as the type. But we get some errors, so it's not recommended to use this raw type. So what we do is we define its type, and in the case of array list, the type we're giving it is going to be what item we want to store, or well, what type we want to store, what class we want to store. So if I type item like so lesser than item and then greater than, then I can only store items in there. And then when I create a new array list, I just give it item like so. When I return the array list here, I'm not returning an array list, I'm returning an array list of item here. And then when I go into the game example here, then when we get the array list over here, we get one of type item. And since we just store items in here, it's going to return an item for us. So I can just remove the cast here, so we don't have to tell it, well, this is an item, because it's obviously is an item all the time like that. So now instead of having, and there we go, the warning was removed, because now we don't have the raw type. Now we're using it properly, where we just define the type. Alright, that's the wrong one. To the player here, where we define the type when we created, and also in the variable here. So we add item there and item there. And the only reason why we can do this is because the array list is written as a generic type. You can't just do that to anything. You can't like, oh right, we create a new item. Obviously we can't create a new item, so a new health potion, and we can't like do a string here, like I want to store a string. It doesn't make any sense. So if we've written our class in a specific way, then we need to supply it with a type that we're going to use. We'll see that in just a few minutes. I'm going to start with just running this program, and we'll see a difference to it. So now if I open my inventory, it's not going to show any items because we don't have empty slots. We just have a completely empty inventory. And if I go back to the map and go into the house to pick up all the goodies, so I go over there you go, and then go up, pick up all these things. So first of all, if I pick that up, I now have one item in there. So go back to the map. If I continue to go up and pick up another item, then I can see that well, I have those two items. Go back to the map, it's now 3. Well, option number 3. Oh, that's the wrong thing. There you go. And finally, let's pick up the last thing. There we go. Come on. There you go. So now if I check the inventory, I will have 4 different items, and then go back to the map. And if I use something completely, so if I, let's say I drink up the health potion, it's not going to leave an empty slot there. It's just going to have, well, the recall potion as the second thing to have, just because it's not really referring to specific indices when they are stored. They are well, they are in a way, but everything that goes on behind the scenes, so you're just going to remove that element completely, and therefore we just get elements 0, 1, 2, which is disarm kit, recall potion, and tiny health potion. So the reason why I use the array list as an introduction to generic types is because it's very useful to have. I've used it before in examples, even though you probably didn't realize. In the last lecture, the one about yeah, the same thing happened. I typed too fast, so when I was supposed to give it an option, I changed the code. But in the last lecture about the doors, we had this room, and then we added a doorway to the room. And what that was a array list in the room that just kept all the well, this array list of all the doorways, so I can just tell it, oh right, I want to add another doorway, and another doorway, and another doorway. I didn't have to define how many items would be there. One thing worth noting though is, even though we don't have to define how many items we store in the array list, it still has a size. I don't know exactly what all the defaults are, but it sets to an initial size, and then if we well, add too many items to it, so it exceeds that default size, it's going to increase it by an amount. I don't know if it's doubling it or something like that, and you can change those values if you want to. So it has a specific size, but it's going to sort that out for us, so we can just add more items to it if we want to. Right, so this was the introduction to generic types, so let's see if we can create our own. So now we don't need these guys anymore. So I'm just going to close all the classes we have. There we go. So the first one is going to be very simple and very silly. It's not going to do a lot. Generic class example. And we need to get a type. Well, we want to get a type that we're going to use. And what we do is just do similar to what we did when we used the array list. Is we do lesser than, then a name of the type, and then greater than. So now I have a type called T there, and then I'm going to write the class in here. And I want a field of that type. So then I can just use T as if it would be any other type. I could use it as if it would be a string. I could use it as if it would be a player from our game, a map from our game, a integer, or anything. I could just use it like I would use any of those types. And I use T here for because it's a type, so T for type. So yeah, here's the constructor, generic class example, and then I can just use it here as well. So I want a parameter of that type. Okay, and then since they have the same type, I can just do my field equals my parameter. And finally, I can use it in a method here, get value, and then I'm just going to return the value of the field. Okay, so this is a very simple, very silly example. Let's save that here. Right, so what it does is, when we create the class, we're asking for a type here, and then we can use that type as any other type. We don't know exactly what type that's going to be at the moment that we write this class here, but we can use it. So we have a field there of that type, we have a parameter there, and we're going to return that here. So how can we use this? Let's see. Let's go to the interactions pane. This is a good example where we can use the interactions pane. So generic, there you go, generic class example, and then like we did with the array list, we just do it like that. So we tell it we want a generic class example, which is the class we wrote, and it's asking for a type, so we add a type string because that's the one we want to use in this example. So I can do string example equals new generic class example string, and then we give it the constructor, well, the parameters for the constructor, sorry, and that's asking for one parameter of the type T, and we have defined T to be a string, so therefore we want to give it a string. Hello, there you go, and that was created without a problem. And then we can get that value, like doing string example dot get value, and when we have that value, we can just print it all out, and we're going to get hello. So like I said, this example is a bit silly. There's no real reason to store just any value like so, but just to demonstrate, I'm going to import the scanner as well, and then if I do the same thing that I just did, that thing, but I'm going to use a scanner. So a scanner, and then let's call it scanner example, and then scanner. So as you can see, we can use it for any type whatsoever. Alright, we didn't have room for it. Let's make this a bit wider, shall we? There we go. Right, so I'm creating like this, but now if I create it, I'm going to get an error. And the reason is I'm defining it, so its type is a scanner here, and then I can, well, then I give that T. The T will get the value of a scanner, but then my only constructor that I have is of the type scanner. So there's no constructor of the type string. I'm trying to give it a string, but there's no constructor defined like that. Of course, I could in the class head define a constructor that had the type string, but well, I'm not. So I have one scanner, so therefore I will have to give it a scanner when I create it, which I can do here. New scanner. Yeah, we'll run out of space here anyways. System dot in, like that. So that's going to create that thing in there. What did I do? Invalid verbal declaration. I don't know what I did actually. Can't see where I did wrong. Let's type it again to see if what I did wrong. If it was a typo. Here you go. Scanner. Was there too many parentheses? Yeah, probably. Yeah. Oh, yeah. Sorry about that. There you go. Scanner example. So now we can use the scanner all of a sudden, the scanner example, and refer to that without a problem. So I can just do scanner example dot get value. So I get the value there, and then next int, for instance. That's totally going to work. There you go. It's going to ask for an integer there. So like I said before, it doesn't really make sense to just store a value like this, but this is the first example, so bear with me. I'm going to show more examples later on. One last thing worth noting before we go to the next example is that we can't do the following. So I'm going to add a 5 there, and then I'm going to do integer and int. So I can't do this. I can't use this integer example. It says type has incompatible bounds, and it basically means that we can't use these types, well, int as a type, because int is a primitive type, and you can't use them here. You need to have a class or something like that, some other object type, rather than just these primitive types like int, float, boolean, double, char. So you can't use them, but there's actually a non-primitive integer, which is just called integer, like that. And one good thing that we can do is convert them just back and forth without a problem. So I could do like integer and still just add a 5 here. I don't need to create an integer object, so that works perfectly fine. So if we take a closer look on that, we can do like integer a, so that's a variable, and we store 5. So I can store 5 in it, even though we should store an integer. And I can also do int b like that, so that's a primitive type, and then I do it like that. Create a new integer and store it. So I can just store it back and forth like that, and that's called out-of-boxing, and like, I'm not sure what the opposite is called, but we basically automatically do that. That's the Java compiler doing that for us. That's just a little side note. So you can't use primitive types, but we have specific versions of the primitive types that are non-primitive. But yeah, so that's the first example. Let's take a look on the next one. So hopefully that is actually doing something, which is going to do. So let's see. First of all, I want to import random generator. So I'm going to work with random numbers here, and then we can do public class random element example. And I'm going to give it, we want one type, but I'm going to tell it to be called E, because it's going to be an element rather than just any type. And first of all, we need the random object here, private random, and then after that we want the actual field with some values. And since the type I give it can be used like any other type, I can just make an array out of it. So here we have an array of the type that we supply it with. Fair enough, I think. Public random element example, and then I can simply supply it with a parameter there with a array of that type, of that element. So the element is E, and then I create an array out of it, and therefore each element in the array will have the type E. And then it's just a matter of doing this dot values equals values. Right. What do we want to do then? Well, this is basically going to give us a random element. That's why it's called random element example. So therefore we need a method that returns one element, and we do get random value. Or well, it could maybe say get random element, but never mind. And then we want to return, oops, I forgot one thing. We need to actually create a random generator as well, like this. There you go. But if we've done that, then we can get the next integer. So that's just a method of the random object. And what we do here is that we get that has the lowest value possible is 0, and the highest possible value is 1 less than values.length, which basically gives us a random index of this array, and we're going to access that element and return it. And that element is going to have the type E, and that's why we can return this without a problem. Alright, so there you go, save that. So how can we use this? Well, the first example I'm going to use is to randomize a few names. So I'm going to have a variable called names here, a string array, and we can have Anna, Ben, Caroline, David, and finally Eric. There you go. So 5 names. Awesome. And then we can create this random element thingy. So random element example. So here we want to store a variable with the type random element example, and we supply it with the element type of string. And let's call this random names equals new random element example. And of course we just give it the type that we want E to have, and when we've done that we just supply it with the constructor, because we're asking for a string array in this case, because E is of the type string. Right. So if I do it like that, we have a random names object, and then I can do system.out.println random names.get value, like that. Get random value, silly me. There we go. So now I got Anna, Caroline, Ben, Anna, Eric, David, and so on and so forth. Caroline there. So we can use this for strings if we want to, but maybe we want to use it for another type of array, an array of something else. So let's see if we can do that. So I'm going to define something else. Random element, uppercase R of course, random element example and of integer, and I'm going to call it random Fibonacci. So I'm going to give it a random Fibonacci number, well, a number from the Fibonacci sequence, but of course not the whole one because it's infinite, but just the few ones I define. So new integer, and since this called that I just mentioned called autoboxing, we can just define the numbers like this: 5, 8, 13, 21, 34, and I'm just going to go to 55, nothing more. There you go. So and I did something wrong again. Here you go. There you go. I forgot the brackets there. So I just create a new integer array of the non-primitive integer type, and then I give it the integers, well, the first integers in the Fibonacci sequence. So that's going to be the type that we have here, the values type. Well, the values basically, and the type rather is integer. So we can have an integer array that we accept. So if we now use this, we can get random Fibonacci numbers of the ones defined, of course. And then we do random Fibonacci dot get random value. And I can't spell today. Fibonacci. Where am I? There you go. So 3, 1, 1, 13, 5, 3, and so on. So as you can see, we get random numbers, but they are not any random numbers. They are from the Fibonacci sequence, and we get more ones than anything else, just because we have multiple ones in the sequence. We have 2 ones here in the start, like that. Right. Awesome. So let's see a final example on how we can do some more advanced things here. I'm not going to show everything you can do with generic types. You can get pretty advanced with generic types, and that's outside of this course. It's not a part of the course, but I'm going to show you one more example of how we can get something a bit more advanced. But like I said, the most advanced things are not a part of this course. So generic class example 2, so that's the another one, and I'm going to use element like so and element 2. Right, so I'm defining 2 elements here. So to do so, I just give it, well, I do like before, lesser than, and then the type, well, the name of the type, but then I just do comma and add another one, and we can go on and go on and go on. So we have E3 there, but I just want two of those, and what I want is private so an array of the first type called values, and then an array of the second type called values too. So I just want two arrays, one of each type that I define. Right, and then I need the constructor. So basically the constructor is going to be as simple as the other ones. It's just going to ask for these two values that I want. Of course, it's a constructor like any other constructor. There's nothing special with it, so we can do whatever we want in there. But yeah, like I said, it's going to be a very simple constructor. Values equals values. So just store the parameter values into the fields like the following. There we go. Right, so what do we want to do with these things? Well, I want, when you define these two, I want to see which one of those are the longest one and then print that out, but also print the shorter one out next to it in a specific way. And it's going to be a example, of course, so there's no real usage of it, but I hope you will get the idea of it. Right, so public void print, so we want to print out the value of this generic class example, basically. We want to do it in two different ways. If the values, like the first array, if that one's length is greater than or equals to the second one's length, values2.length, like that. If that's the case, then we want to print it out in one way, and in another case we want to print it out in a second way. Okay. And to do that properly, I'm going to add a help method here, a private one. And what I'm going to do is actually make a generic method. So that's also possible. You can make a generic other things, not just generic classes. So what I do here is I define the first. Well, I define two types: the normal type T and the other type T2, and then I have the long array. So I have the longer array of the two there, of the first type, and then I have the second array here of the short type, like that. Right, so then I get the long type and the short type. So I define two different types, and you can totally do that. When you create a method, you can make that generic by doing the same bracket that we had up here after the class name. We can have that before the type, the return type. So that's just different location of them. And when we have that, I will just want to loop through the values of the longer array, long array dot length, like that, and print out all those values. Sorry, like long array, and afterwards we might want to print out the shorter array as well. So it doesn't really make like too much sense, I guess, but what we're doing here is make sure that the longest array is the first one that's being printed out, and then we have the short array at the right hand side. Well, if they are the same length, they will, well, be the same length, of course. So if I is lesser than the short array's length, then we can safely just print that out. So short array I. Otherwise, well, we don't have any elements there, so no matching. That's not how you spell matching. Matching. Sorry, no matching value. There you go. And then there. So right. So now if I compile this, it's not done. Here we go. What did I do? Short array. There you go. Silly me. Short array. Right. There you go. So now it's working. So what we want to do is that if the first one is the longest one, then we want it to print out it with values as the long array. If that's not the case, we want to use the values 2 as the long array. So how do we do this? Well, if we do this dot print and then give it just the values and the not short array, values 2 here, values 2, right? So what it does is we're calling this one here, we're using the first one here, the first values, well, not the first values, but the first value array rather, as the long array. But we also do this. So we define the type that we want to use, and obviously the first type is the type of the first array, and the second type is the type of the second array, like that. So if the values array is the longest one, we send as along as the parameter for the long array. But we also need to tell it that the type that we're using for the long array is this type that we send along. So we're using the type that we get up here to send it along even further to something else called t. And we're using that just because we can then do the opposite here. So if we want the values 2 to be the longest array, then we can just define that as putting that type first and then the e type there, and then finally we swap these around as well. So if I compile now, it's going to work perfectly fine. So we create a generic class example 2 here, we give it 2 types and then 2 arrays of those types, and after that I'm going to print out the arrays depending on which one is the longest one. So let's see if we can get a example here in the interactions. Generic class example, and I want it to be of Boolean, so that's the primitive type Boolean, and then we do string. So we have those types. So Boolean will be the first type here, that e, while the string will be e2 there. So it's just the same as when we had just one, but we add a comma in between them. So it's lesser than all the different types, and then we add a greater than. And of course we need the same size here, so we need two types because we're asking for 2 types. Right, just call it test and then new generic class example 2. And a Boolean and string, like so. And then we need to give it these 2 arrays, so let's do that. So what should we use? I'm just going to use some simple things here. New Boolean true, false, and false, right? And then what I can do is, I don't know, new string test, another test, more test, and then a final test. So as you can see, I've given the second array more elements than the first array, like that, and that's going to do so when I print it out, then the second array, which is values 2 here of type e2, that one is going to be used here. Well, that one is longer, so therefore we're going to run this code here, and because we're running that code, we're going to send along e2 as the t type, and then we're going to send along e as t2, and then we will use values 2 as the long array. And therefore our output, which we will see now, is going to look like this. So we get test, another test, more test, and then final test, like so. And then we get the other values here, true, false, false, and no matching value, because the latter array is too short to give us any further values, like so. Right. Good. Yeah, sure. I don't know exactly why you would have this. You can print it out like that. But one thing worth noting is this part is useless, because it can detect which type these ones have. So if we just send that along to the long array as the long array here, it will realize, well, right, the type here is going to be E, because that one has E as its type. And the same thing goes here. If we send that along, it's going to detect that T is in fact E2. So if I compile it now, it's not going to make a difference, so we can still do the exact same thing. So let's try that out. That's the exact same thing that I just typed, and then print out. So it's not going to be a difference at all, so that's nice. So what's happening is basically it understands what's going on, so we don't have to specify the types here when we call this method. It's going to realize, well, values has the type E, therefore this T here should have the type E. Of course, we still need to specify that we're looking for two types, otherwise it wouldn't work. Right, so let's, well, make a last example there. So generic class example, and instead of defining it like so, I'm going to define it with 2 integers. test2 and 2 integers here as well. Just to show another example, nothing too special. So new integer, and what I want is well, 1, 2, 3, 4, and then the second one should have new integer 20 and 1, for instance. There you go. And now you can see that I did it wrong again. I type a lot of wrong things today. What did I do this time? Yeah, I'm silly. I'm so sorry. I shouldn't make mistakes like this. There you go. Correct types of bracket, of course. And now if you do test2.print, we will see the following there. So we get 1, 2, 3, 4, 21, and then no matching values. And the reason is the first array is the longest one, and therefore we print that one first, while the second one is shorter, and therefore we print it out there, but then we don't have any values in the end. And it checks the length of them, and it's going to use them as integers because we defined that we want 2 types of integers. So E and E2 will be integers in this case. So that's generic classes for you. There are a lot of more generic types you can work with. There's some more advanced things you can do using wildcards and whatnot, but that's going to be outside of this course, so it's not a part of this course. If you're interested, then you can well, take a further look yourself. But this is about it for now, and something very handy which has a lot to do with generic classes is the array list. It's very handy to use. So let's see what we have learned today, because now we're very near the end. So first of all, we spoke about abstract classes, and we can define it like that. We just did public abstract class item, and then all of a sudden the item class is abstract, and therefore we can't do what we do there in the static void main. We can't create a new item and then give it to parameters, and as it says there, not possible since the class is abstract. Exactly. Right, then we can add an abstract method. So we add public abstract boolean use item, and observe that we have to add that in an abstract class, otherwise it won't work. So that's why we made the class abstract in the first place. And there we can see that we can actually create a new health potion if that health potion class is extending item, so it's a subclass of item, and it's also overriding use item, so it's defining how we're supposed to use this item. And therefore we can still use item.onUse, even though the item class itself is not defining how to use the item. It's just their public abstract boolean use item. So therefore, when we have that abstract, we can still call it, but since we can't create any objects of an abstract class, it's still going to be fine. But then when we create objects of the subclasses, we can still call item.onUse. After that, we spoke about generic classes. So we just add that in after the class name, so lesser than t greater than, and that's our type t, and then we can use it like any other type. So as you can see, the type of the field there, the type of the parameter, and finally the return type of the method. So you can use it like any other types, like string and scanner and integer and whatnot. So there you go. And then when we have a generic class of some sort, we just create it like so. So we have my class, and then we do well, like that, we give it a string because we want to store a string for some reason, and then of course the variable name, and give it the value of the new object that we create. So we create it by using new my class, give it the type of the generic type there we're missing, and then we just give it a constructor which is hello, which is a string, so it's all right, and then we can print it all out by doing test.getValue. So it was a very simple class there. And then we have an array list here, and we have an array list of an integer rather than just an int, because you can't have generic types that accept primitive values. And this array list allows us to have a list, dynamically increasing size of a list where we store integers, but because of this called out-of-boxing, we can still just add 10 or 7. We don't have to create new integer 10 or new integer 7. So that's how you create generic well, objects of generic classes. And then finally we had generic methods, where we just define the types there before the return type, and then we could use that like we did in the generic classes. So in this example we have public, and then t t and t2 as the type, and then the return type, the name, and then we have some parameters using those types. And of course, you can then use those parameters without knowing exactly what type we're going to use. When we call them, we just call them normally, or we can define the types when we call it as well. That's perfectly fine. And that's about it, actually. So don't remember the questions and exercises document. So the questions are to see if you've learned what we have gone through today, and the exercises are there so you can practice what you've learned, and the further exploration is to continue on with some further coding there, some more advanced things that is a bit more advanced than the lecture has covered. And the answers to the questions exist, so you can check if you were correct with the answers, well, with the questions. And then we have the possible solutions to the exercises, so you can check a possible solution. Observe that that's not the only possible solution. While the further explorations, of course, has no possible solution, because it's just you that is supposed to continue on your own. But that has been this lecture. So this has been Thinking with Objects, lecture number 4, Abstract and Generic Classes. I've been with VSWE, and I hope you enjoyed it, and I hope to see you next time. About, what's that one? That's about interfaces, not the graphical ones though, but object-oriented interfaces. So see you then.